So that's it. We are going to talk about our connector development in China. This is a very funny story. The current situation of China's continuous development, because everyone knows about electricity. These countries in Europe, America, and other countries, they take precedence over China. People are in the era of electrical appliances. We're still using kerosene lamps, other electrical appliances. In an era of rapid development, we are still only using it for very low-end people's livelihood. The same goes for the connector, because it is the part that connects electrical and electronic equipment. So what about the Chinese connector? It is indeed an import, no matter from the technology itself. Is it good to develop from this? We really need to learn from European and American companies. Learn from them. So is this one. This is the beginning of the 20th century. This industry is just starting to develop in China. This development, of course, we talked about it earlier. It is also because of this widespread use of computers. So the connector is in China, especially for Chinese companies. The earliest application of connectors is just one word. It's a pathetic word. We are all talking about copying. Or as some people call it, a little more euphemistically, copy. Well, the first phase of our connector development, that's copying. Holding products of foreign brands, come directly to speeding. So there was a term called speeding. Then completely. Do it their way. I don't know what to say. I don't know why. Just don't know anything. Just copy it completely. And then we will create a batch. This Lenovo industry practitioner. Of course, in those days, we also have a group of people working in foreign companies, real practitioners. After learning a certain amount of knowledge, we started to change from copying tapes. You start copying, and then you're done copying. We make a little modification. This modification is part of our own understanding. Is there this knowledge we have about connectors? Of course, this perception may be biased. There is a bias of partial perception of the entire electrical system. There is also a job for this connector, cognitive bias. Well, what about after the change? In modern times, just a few years, are there many employees in our industry? Connectors are more widely used in the industry. And so we started to have some innovations. Well, some innovations are starting to emerge. But what about this innovation? There are some phenomena. We start from this innovation process. You see some of our weaknesses. What is this flaw? There's a very special place here. As mentioned earlier, our connector is an imported product. This knowledge comes from outside. So all our colleges and universities in the country, all our educational institutions, in fact, there is no system. This so-called education. Let's show you how to learn and understand connectors. That in our real practitioner industry. In our team, what is everyone's understanding of connectors? Again, based on practical applications. And some of the strengths of the companies themselves. So it's very fragmented. There's this fragmentation. It also leads to our understanding of connectors. Produce some. It's just a little bit of self-justification. Some claims. That combined. What knowledge do we need for the entire connector? There's a very simple generalization. The first one is that we need physics. So what we do is we take a mechanical structure. To achieve electrical connectivity, both of these are physically necessary. What's missing? Whether it's the structural part or the electrical part, it's all physics. In the process, our physics aside from electronics and electricians. The mechanics. It's all about the hard mechanics. The hardest mechanics. This is the basics of connectors. Well, with these mechanics, we need to do some FEA. Simulation analysis and process analysis of phi. We call it surface treatment. That involves chemistry. It involves material science, chemistry, and material science. Ah, what about material science? It also involves our material processing and materials manufacturing. So the whole connector, it's designed for a lot of different disciplines. There is a lot of knowledge about design. Ultimately, throughout the design process, we can't live without numbers because it involves tolerance analysis. It involves statistics. Therefore, it is closely related to mathematics and statistics. So looking at the whole connector, it's designed for so many disciplines. Under this premise, we can really logically put the connector to its application base. Can you straighten out the logic from application to design? There is this opportunity, or there is this platform. Not that many, and that's what I'd like to share with you. A very fundamental reason I wish you all were here. Learn from each other, raise each other up. Then after all of this course, a very core, how can we integrate this knowledge? Apply this knowledge to, or apply to the application of our connector, the application of this mechanical structure, and our design? Here's a more creative one. More creative. We call it modeling. Ah, we're going to model. How about now? A lot of universities have started modeling competitions. There are modeling competitions. What about this so-called modeling? It's easy to understand. It's actually easy to understand. I need to make something. For example, we often talk about it in our contact. Our terminals need to have a structure. Right, our terminals need to have a structure. This is the structure of the bean sprout petal. But no one knows. How do I make it with this structure? This structure, in the end, its lifespan, it's this. What is the status of these various applications? Then I need to build this structure. Build different models according to my actual application. For example, I can copy our male and female terminals. When matching, I built a plugged model. A model with lateral forces. And then I analyzed the force on it, and its pros and cons, and the relationship between it and the material. This is a kind of. Another way is, I want to know my entire model. What lifespan does it have? What kind of material do you need? What size or fastness do I want to order? Then I need to decide at this time. Building a model of the forward force, the establishment of these models, the establishment of a separate model. It is precisely our connectors that do in-depth research, make some key structures, a fundamental aspect of component research. Fundamental means and methods. That's what we said about design. These things were shared with everyone. Well, I was fortunate enough to be at the beginning of the development of connectors. I have worked in some well-known foreign companies. There are also some, we have stayed in some private enterprises in China. What's the basis? Found compare the more regrettable thing for everyone. The entire industry, our entire industry of contacts, from users as well, also from our manufacturer, from our practitioners as well. Everyone agrees with this. A big brand with qualifications and experience. And for some of our local emerging new brands, or a new manufacturer. And we all have our doubts, or a certain hesitation. Of course, this is the same as all industries. The brand, it exists. But I want to talk about connectors, because it is derived from the application side. Let's go back to our manufacturing or design side. And in fact, the application of our connectors at this stage. We happen to. It's all about the design of the window. That is, I will design some products for customers to choose from. This one. In fact, with the development of the original connector industry, it's a little counterintuitive. Of course, this is my personal feeling, my personal opinion. Then I hope to. In the future, we will have some local national brands, able to have rapid and core development, Can you talk to some foreign brands? Can compete. Can do this kind of synchronization. A high level of competition. Okay, so that's it for my sharing.